Hello, everybody. In today's session, we're going to be talking about the power rule and chain rule. So these are pretty much the most um, widely used in calculus that you will encounter, and it's basically the fundamentals of calculus. So the power rule and chain rule is used to differentiate functions. So if you have a function you want to differentiate that, you use the power rule and chain rule. So let's go over some notations. So you could write derivative in this form, or you could use Leibniz form, like this. Leibniz form essentially tells you what you're taking derivative of. Right here, if you use another notation, you won't really know what you're taking derivative of. But using Leibniz form, you know for the function you're taking derivative of, you're taking it in respect to x. Now, if I change that and make it dy, you're essentially taking derivative if the function contains the variable y instead. So that's what Leibniz form means. And then if you're a physics student, when you take derivative, you'll have a dot on top or something like that. Now we're gonna go over an example, general notation of how to take derivatives. Pretend you have a basic function like this, ax n to the power of n, and you want to take the derivative of this. So you could write it as you do it n times a is a coefficient, x to n minus 1 power times the derivative of your original function, which is f of x. And you know that this essentially is your original function, this variable right here. So that is essentially power rule and chain rule mixed together. But if we have another one, let's make it like x to the power of n, and you want to take the derivative of that, it would just be n x power of n minus 1. That is power rule. What chain rule is this? That if it's a multivariable one, you have to take it for the derivative of the variable inside. So you take the derivative of this variable that you have, so derivative of f of x. But usually, since this variable's personal power has already been taken derivative of, you don't need to do that again, because any variable's derivative would just be 1, and any constant derivative would just be 0. So that is a crucial aspect when you're learning derivatives. So now let's do some questions to practice. So if I give a function like 3x power 4 plus 5x squared plus 6, you want to take the derivative of this function, it will be 3 times 4, which would be 12x cubed plus 10x. That's it. Really simple. Now, what if I have something like you want to take the derivative of sine 3x squared? Now this thing will be trickier. So first of all, you do power rule, which you get cosine 3x squared, because the derivative of sine x is cosine x. This is something you have to memorize, and we'll go over that in a future lesson. So cosine 3x squared. But remember, chain rule says that you have to take the derivative of your variables, which is 3x squared. So you have to take the derivative of that, which would be 6x. So that is essentially uh, a way you're applying chain rule to. But now after you took the derivative of this variable, you do not need to take it again. So if you take the derivative of this 6x again, which will be 6, you essentially did it wrong. So that's just something you need to know. Also, here is a trick when taking derivatives. If you encounter something like when you're given a constant and you want to take raised to a power, and you want to take the derivative of it, well, there is some exception for this, because this would be equal to ax times ln a. So there are some derivative rules that you essentially need to memorize, because this doesn't really apply to power rule, because this is sort of some kind of exception. If you do power rule, you get x a to the x minus 1, which won't be correct. So that is something you need to be careful of. And I hope you enjoyed my introduction to power rule and chain rule.